Welcome everyone to part 2 of our series on compression. In this part, we're going to talk about compression configuration and how to test compression. First, compression configuration. Choosing the right columns to segment data by is the key to achieving good compression ratios. After your compression, keep in mind the data is reorganized and stored in column rather than row order, and therefore uncompressed schema configuration cannot be used to further optimize query performance in compressed chunks. Segmenting your data with your query patterns in mind can maintain query performance and even boost it after compression, so keep that in mind. Some additional notes. Many of the concepts that apply to hypertable compression also apply to continuous aggregate compression, and the biggest reason for that is because they are both hypertables underlying. For continuous aggregate compression, if you do not define any options manually, the default is a group by column of the CAG configuration, and the order by is a time bucket column of the continuous aggregate configuration. So how do you select the proper columns? First, you need to try to determine the uniqueness on a per chunk basis of the different columns that you have. Keep in mind that bundles of compressed data go into rows of maximum 1,000. There's two methods that you can try to determine uniqueness using. Distinct count is a common method, and also you could use PG stats view and underscore distinct column to try to show the cardinality. Keep in mind that the column with lower cardinality gives better compression ratios because theoretically there are more rows of data to segment within that chunk. Some additional notes about selecting proper columns. You can use more than one column to segment data, but just like any other configuration, you want to test the compression ratios and make sure your performance is good before committing to a policy. Also, the main time partitioning column is used to order data in either ascending or descending order. Descending is the default. Columns used as search keys and filters that can't be used to segment the data could be included in the order by to act as an index on the compressed data. Let's walk through the steps of compression testing, and then I'll go through this using Popsicle. First, you want to identify the oldest uncompressed chunk to test compression. The reason for that is because you want to isolate the test so that it doesn't affect your newest chunks and most recent data write and read. Then you want to get the query-based execution plan against the identified chunk to give you a baseline before compression of what the performance of a common query is, or common queries. Then you enable the compression on the hypertable or continuous aggregate, and then manually compress the identified chunk that you're testing, which uses the configured segment and order by columns. You check the compression ratios to make sure that they are decent and see whether you can improve them if you want. Then you get the query execution plan after compression to compare that query time with the plan before compression. In other words, comparing compressed data to uncompressed data to make sure that you didn't have a negative effect. And then you want to decompress the chunk manually if more testing is necessary, because to change the settings, you have to decompress, modify via the alter table, and then recompress manually to take on the new settings. Some additional notes. Using one or a few chunks to test, again, allows you to decompress if the compression settings need to be adjusted before committing. And certain columns, even though they can lead to lower compression ratios, they could have better query performance. So there might be a trade-off, a decision you have to make between the two. So to test this, I'm going to use this simple device data. The schema is listed here. And if you look at the chunks, I'm finding the oldest chunk here is Hyper 1597 chunk. So that's the one I'm going to test with. Hop over to Popsicle, and first I am baselining the uncompressed data query time. So I copy that just to have it as a reference to compare later. Now I'm going to look at the uniqueness of some of my column values, and remember this is on a per chunk basis, and you can see the chunk designated there. You can see there's about 1,000 rows of unique data per device ID, so that looks like a fairly good segment by, keeping in mind that segment by bundles 1,000 rows together. Let's also check out the device type just to see what that looks like, as well as another option. This would also work. It has over 6,000 rows per chunk that are unique, so it would end up being a little bit over 6 bundles if you keep in mind the 1,000 row bundle. The first one I'm going to test is device ID. So I'm running my alter statement, and then I'm manually compressing the chunk once the configuration is set up. You can use a query for this, but I prefer to find the compression ratio rather than using a query. I prefer to view it in the console. So if we look at this in Cloud Console, you can see it's about 73.5%. So that's pretty good. So let's hop back over here and let's also test this versus the uncompressed previous performance for this common query I use. You can see here that compared to the previous performance, 3 milliseconds, you're getting about 10 times less than that, 0.2 milliseconds. So it's a faster query even using compressed. Let's also test device type just to see what effect that has. So first thing I want to do is I have to decompress the chunk to reset it and then run my new alter table configuration to test device type. So you can see there the designated segment by as device type. Now manually compressing the chunk to use those settings. Again, I'll go back to the console to see what the compression ratio effect is. And you can see it's about the same compression ratio as using device ID. Now I want to test compression again, see what effects that has. You can see it's a little bit slower than device ID, but still not bad and still better than the uncompressed data. If you want to test other things like order by or even a multi-column segment by, you can do that too. I list the query here for multi-columns, but for now I'm going to decompress this chunk to reset it and then decide what I want to do before committing to a policy. Maybe it's more testing. So that's it for the walkthrough. Hope you enjoyed this part. We'll see you in part 3. Thank you.